Hi and welcome back. Now continuing our look at the incredibly deep dynamic systems in XParticles, we're going to take a look at a new one which has been added in XP4, and this is called ExplosiaFX. Now this in itself could be its own plugin. It's so vast and intricate. I will show you as much of it as I can, but it's a lot of fun to play with, and I think I should just show you because it's awesome. It was actually an XSI plugin that Insidium brought over to XParticles, and they've integrated it fantastically. So what do we need for this incredible fluid simulation system called ExplosiaFX? It's actually pretty simple. We need a source, so I'm going to create a torus to emit some fluids from. It's going to be our source. Let's give it some motion as well. I'm just going to chuck a lazy vibrate tag on there. Make sure it's shaking around enough. Give it a different seed. Press play. Yeah. So this is going to be our source. And then we're going to add an ExplosiaFX container. So we can get that from our dynamics objects. And you can see here we have this ExplosiaFX object. And right away, familiar sight, we have a domain object, or a container you could call it as well. But it's a voxel domain. So basically it's made up of multiple cells. And we have our bounds, minimum, maximum, voxel size, all that kind of stuff. And that should be fairly familiar if you've looked at the other dynamic sections by now. I'm actually going to reduce our size of our torus right down so it fits nicely in the container. And then if I press play now, nothing's going to happen. And I'll tell you why. It's because, let's make my icons a bit larger so it's easy to see in the stream. There we go. If I press play now, nothing happens. It's a bit slower because it's tracking the velocity of the torus. But we need to add a tag to the torus and tell it to start emitting something. So we go to XParticles tags, and it's under this sub tag here called library tags. Now, it's not too much to worry about. It's just a bit deeper in the hierarchy to find, or we could always do our commander, which is, so you do explosia, and then you've got these 4 explosia items, and we just need a source. So throw a source on there. Now when I press play, we have a smoke simulation. And you can see how cool this is. It's pretty quick in the viewport. We're getting some really interesting looking smoke and motion. And what a fluid simulation essentially is doing, and we've dealt with these in the other sections where we were looking at the flip domain, it's solving the velocities based on sort of certain properties of gas. And this particular one is fluid dynamics. So it's looking at the motion from one cell to the next based on temperature is a huge one in fluid simulations like this, where it's gaseous fluid simulations. Temperature is huge because it dictates buoyancy, and buoyancy is just purely the upward thrust, or if you have negative buoyancy, your whatever your object or whatever the substance is will go down, and that kind of stuff. We'll get into the details on that in a bit, but you get the idea here. We can change the voxel size to a bit larger, and it'll solve much quicker. But obviously the smoke will be a bit less detailed. I can move the container around and it'll just track a bit lower. That's nice. And that means we'll get a bit more headroom to simulate the smoke there. And yeah, so these are the basics. We've got the voxel sizes, we've got the bounds as usual. This works a little bit different to some of them. You can actually just bring in an individual wall. So if I cut it off there, for instance, you notice it carried on because it hadn't updated. There we go. So we can isolate exactly where we want this smoke. That will change the simulation, by the way, because you're changing the bounds of the simulation, and it might push the smoke off to one side, even if there are no collision boundaries. Talking of which, we actually have some collision boundaries, and you can see as I press these, just like in the flip domain, they highlight to show you which ones are colliding boundaries. And let's actually move the torus right up, and we'll see it collide with the top of the container. And there you go. So it's a bit like smoke filling a room or a container. That does seem to eat into the smoke a little bit, but it's a way to kind of maintain it in a closed system. Okay, so let's take a look at some of the basics. So we're not going to look at advection at the moment. We're not going to look at the adaptive bounds right now, but let's take a first look at what channels are. So currently we've got 3 channels activated: smoke, heat, and fuel. And what they're doing is we're having this torus generate these channels. So it's generating heat, it's generating fuel. It's also producing curl, something called curl and pressure, but we'll talk about that in a bit. Now you'll notice that smoke is at 0%, but when I press play, we can clearly see that there's smoke, or at least what is meant to be smoke, is showing in the viewport. And that's because we're generating enough heat and there's enough fuel that it begins to burn. And when it burns, it produces the smoke channel. So if I go to our display tab and I click on temperature, that's our heat. And that's something that drives the vorticity, the velocity, almost everything in a fluid sim is temperature dependent if you want realistic looks. And then we've got sort of fuel, we've got the smoke, the fuel, which to be honest is probably invisible, or you can just about see it down here, but it's burning very quickly, you see. So essentially it's burning off very quickly. We've got this display mode called slices. We'll talk about that in a second, actually. I won't get too ahead of myself. But yeah, you can see that we are looking at different channels, and that's important to know because we have this color one down here, which we'll deal with later. Velocity just gives you an idea of which way the velocities are. We've dealt with velocity vectors and stuff before. And fuel on its own, like I said, and then fuel and smoke. So that's the default, by the way. Fuel and smoke is the default. And fuel is also burning fuel. So it's the fuel can be unlit or not burning or non-ignited, if you like, and still be showing in the scene. So that's something to worth. I would preferably have a separation of burning fuel and non-burning fuel, but in the current system, it just worked with that. But you still can get some excellent effects. And you'll see if I uncheck the smoke channel in our container here, we just get the burning. And currently it's still, if you imagine, it's still simulating the temperature. So you can see the container is actually adapting to that channel, but the actual fuel is right down here, you see. Okay, so next up, we can take a look at those display parameters. Let's put our smoke back on, and we'll come back and check out color later on. So press play. Let's get some fuel into our system and check out our display tab. So in this display tab, we can change some properties of how the smoke is displayed and previewed. This is important because when we're looking at sort of more details in terms of the solving and the simulation stuff, this is a good way to check it out and make sure that you're getting a true to simulation visualization. So we've got slices. This will be familiar to anyone who's used something like Turbulence FD. Even in the domain object of XP, there's the slicing sort of for previewing smoke and stuff. But you can increase the number of slices, and purely what that means is, I don't know if it's particularly visible. There we go. That's just about visible there. You can see each, to save on having to display, because displaying the smoke in the viewport in real time is actually quite a heavy task for OpenGL to show you. And so basically the data has to be passed from Explosia. It then gets translated into this slice, and then those slices are then added up to each other, and you see they've got some transparency and blending and stuff, and it gives you the illusion of this 3D volume in the viewport. And so the more slices you have, the more accurate the representation of the fluid is. And you can see here we're getting way more detail, and in fact it seems to be pretty smooth in the viewport. Start to see some voxels where it's getting a bit dense, but you can also then increase the transparency maybe and kind of balance it out like that. So you can see that that's looking a lot more detailed, but it's still not fully detailed because the resolution of the slice itself is still only 64 pixel or 64 voxels. So I'm going to drop the slices back down because you can actually have that quite low. Let's reset our transparency to 30%. And then we can check the resolution out. Now all of these, actually let me go back to 120 slices and press play, and you'll see playback is pretty low. We're at 8 FPS. Still not bad, but at the same time, you know, it's probably significantly lower than having just a few slices. Let's reset that to 32. Play again, we're getting, 12 FPS, so 4 FPS more, which doesn't sound a lot, but trust me, that adds up over time. And if we increase the resolution, let's times that by 4, go to 256, you can see that we're actually getting a more accurate representation of the fluid, but without having to increase the slices. And this does slow things down quite significantly. And you can see here, if I increase the resolution of the simulation, say go to 3 centimeter voxel size, we're starting to see way more detail in the simulation. But if I reduce the resolution down, we'll start to lose that again. So this is worth knowing and worth tweaking on the fly. So if you're trying to get just a general feel for the fluid, you can drop it down to its default 64, press play, and you'll get a much closer to real-time playback, even though it's not real-time, of course. If you want real-time, cache. Always cache. Or render it to a viewport preview. That's absolutely fine as well. So, okay, we've got that, and you can see here, now we're getting this, we can't see much detail in this. Let's zoom in a bit. You can see it's quite choppy, a bit hard to see, and then if I go back to that 4 times the resolution, immediately our detail returns. So you'll just have to find a balance of where you think the resolution should be. If I go even higher than that, it's double that, there's a sort of diminishing returns. So maybe even at 128 will be fine. You know, at this distance, 128 looks fine. And it will be slower. It'll be almost half the speed, but it's still fast enough to diagnose it, if you like. Okay, so that's slicing. And like I said, you can do this with all the channels. They'll respond exactly the same. And of course, we'll get onto the color stuff in a second. But fuel and smoke at the same time is the default. Now, if you have the transparency at 0%, which means it has 0% transparency between the slices, you actually start to lose. If you've got lots of slices, can you see here we're losing the fuel underneath there, so it's actually hard to see it. That's why there's a transparency slider, so you can see stuff underneath, which is a bit more natural looking. And then we have a few other modes that we have. So we've got off, of course. Now, why would you have off? Well, look at how fast it simulates when the display is off. So you got to think about that when you're doing this. Do you need to see it in motion, or do you just want to get to a certain frame, turn the slices back on, and start setting the displays there? Well worth having an off mode for sure. And then we have a couple of other modes. We have center slice. I'll go straight to that, and we'll go back to grid in a second. And that's purely just a single slice, almost like a CT scan or something for our fluid. And you can see that it's just through the dead center of the grid. And as I rotate, it flips to face camera. And that's all the other slices are doing, by the way. They're just flipping to face camera, which gives the illusion. So if you look here, can you see they're going along the x-axis? And now they're going along the z, so it flips along with our container display as well. Okay, so that's slices and center slice. Now we have grid. Grid mode, I really like grid mode. So I'll show you a limitation with slices actually. So if we have geometry we've already got a torus, but I'm going to add another one because you can never have too many toruses. If you have a fluid and transparency on that fluid, and it mixes with geometry in this viewport area, can you see we're getting these weird transparency issues? And you actually can't see the shape of the torus anymore. Well, that's just a limitation of the slicing, sort of a transparency depth thing maybe. But if we go to grid mode, this essentially allows you to, it puts a point into the center of each voxel. Oops, I moved the grid there. Whoops, mistake. Mistakes were made. Over here we, let's get back up to frame 60-ish. There we go. I keep going. So what the grid mode does is it simply puts a point inside the grid of where there is data. So say there's smoke values, and it'll clip below a certain value, but what we're seeing is in each voxel there is a smoke or fluid being solved. It will display it as a dot, and then the size of that dot is dictated by this smoke opacity, and you can kind of multiply that stuff. But you can see the resolution is a little bit low right now, and we have it at 50%, so that means that for every 2 voxels, we're going to show 1 dot. So we're going to increase that to 100, and you can see now much denser, slows down the viewport a bit, but the interaction with our object is much more clear to see, so we can still see the object through this. And I find that one, I find the grid one probably my favorite to go to see the detail in the simulation. Even though it's not very smooth, you still get this kind of stepping. And you can add some transparency to this, of course. And you can even overdrive the resolution as well. So you could say Vox LOD double. And there you go. We can actually see some real detail coming into this. That's kind of what it does on render time as well for a lot of things. So default is 50. Transparency default is 30. And if you press play at that mode, that's actually pretty fast. Even though our voxel size is half default. Or is it half? No, it's the same as default. Okay, so that's the, and we're seeing the smoke channel. We can change channels, of course, temperature. then fuel and smoke. Velocity, obviously we're getting the velocity, so we're getting direction, and although actually that's, yeah, we're getting, you can see there we've got these little velocity vectors just like we have in the flow field or in the domain. And there we go. So let's take a look at, I should just say whilst we're here, velocity obviously shows you the velocity vector. Speed just purely shows you a dot with a weight value, which is then colored from 0 to 1 multiplied by this. And you end up, obviously red, they're moving faster than 200. And if they're green, they're not moving at all. Okay, and then we can increase the voxels there. So these are really cool display modes, sort of almost artistically interesting in themselves. That's not what we're here for. We're here for the explosions and smoke and stuff. And here we go back to fuel and smoke. Let's go back to slices. And let's mess around with the gradients here and the ramping and stuff. Oh, actually, before we do that, we might as well just look at the display of the actual grid itself. We have this drop down here, which is the grid display. We can show none. And when we put it into none mode, you'll see there's still this box around the fluid. All we've done here is hide the grid itself, but the adaptive grid, which is the thing that follows the fluid around, depending on where it is, to keep the memory low and the speed quicker. We show that, but we can uncheck that one here, show bounds. And that means that we've literally just hidden the bounds and we are left with just the fluid. I tend to like to have one of them on, just to kind of get a good idea of where your object or where your fluid is in the system. So we have bounds. Obviously, bounds is just the default. Is not the default. Sorry, bounds is just the outside. It's this minimum maximum value box where your simulation is occurring. And then we have voxels, which I've never ever used in practice, but it's there and it's kind of helpful to just see how insanely dense. You think each of these voxels has to be solved by your processor, poor processor. And this just gives you an idea of how dense that is. I honestly never use that one. Back just means that every time you move the camera around, the grid will display on the back of the thing. We've seen this in the flip domain, like I said. We've seen this in the flow field, and also I think, yeah, it's in the cell automator object as well. All fun things with voxels. So that's back. Base obviously will always stay on the bottom of the grid, regardless of where the camera is. And then let's go back to back, which is the default. There we go. Cool. So that's the actual bounds control display for the display tab here. Let's look at the opacity stuff. So currently we have fuel color, fuel opacity. Now fuel's down here, it's not very visible at the moment, so I think we'll just jump straight to smoke and then we'll come back to fuel in a minute. So smoke color, obviously this is the color of the smoke itself, and we can add in some weird colors here. We could go for a color in the mid. So this is essentially mid density smoke, and this is zero. This is where we've got the thinnest amount of smoke. It goes to a white. With the densest amount of smoke, it is going to this black color. Well, let's change this to a, there we go, like a blue, and we can get some really funky looking effects. Now this isn't going to render like this. This is purely just for display purposes in the viewport and debugging and that kind of thing. So you can see I can invert it and the white becomes the core of the smoke. But the default is this sort of black to white, or white to black even. So low density is white, and then we get this black here. And to be honest, I don't tend to change those too often. It's nice to have a good viewport preview. It's just mostly, if I'm doing anything, I'll be clipping them using the smoke opacity. So you imagine we've got the smoke at its lowest density. The opacity goes to its lowest amount. It basically goes to 0. If I actually drag this one off completely, you'll see our whole voxel domain becomes solid white. And that's because we've just made the smoke opacity 0%. So basically there's no opacity. It's just pure, regardless of density, every voxel is going to be full opacity. So we put the black node or point back in there, and I can move it around, and you can see I can crunch it, and I can clip the fluid. So I can actually clip the fluid, and I can change the knots here. That was the term I was looking for. And We can even do, so we could even have it so that the core is actually transparent as well. There we go. Let's increase our resolution just so we can see this nice and clearly. More slices. There we go. Lots of detail. And you can see, until it has to regenerate, it's actually pretty smooth in the viewport. So you see when I get to the point where I'm like 45 degrees on and it redraws, it hitches. You can see that it goes doop. Well, it's actually, you know, for reviewing, it's actually really quick when it's not being regenerated. So if I invert this smoke color again, we get this, we can see that there. Like I said, we can change the color, of course. Oh, look, this gradient again. And you can see there, we've got this nice, weird looking gradient. Now, we're not seeing any of the blues, I think, because we've got the transparency there. There we go. And when you increase the slices, by the way, you might want to increase the transparency just to balance it out. There we go. So that's the gradient curves. We've seen those before in other control systems where we need to map data to different gradient colors. Definitely a good workflow to stick with. Let's look at our fuel one. And I'll tell you what, I'm going to, well, actually, we can just zoom in down here. Let's do it on a grid just to show you the difference. There is not much, to be honest. So 300, I'm going to overdrive the resolution. There we go. So you get this nice looking bit of fire down here. And this fuel color is the default one. We could load in a preset one, which, say this flame one, and that looks like it's inverted, so we'll invert that. And there we go, we get quite a nice natural looking flame. If I go for something where each time I'm doing this, it is updating and it's taking ages, so I might just turn that off whilst I just change this gradient. That's a lot quicker. I put too many knots on here. If I reset it to default, I'll end up with more. There we go. So I'm actually going to show you a little trick here that I like to use. And in C4D, you've got something called Kelvin temperature, which is translating color. Now, it's not black body radiation, which is how you generate very natural. It's related to it, but it's basically how a temperature translates to a color, or it translates to a wavelength, which is how in real life we see color. So if I put the exposure container back on, we can see our thing is black there. Let's go back to slices, actually, it's going to be quicker. And what I'm going to do is I'm actually going to drag this knot off, and I'm just going to deal with one for the minute. And I'm going to click on this K here, above in the color chooser, color picker. And you can see we get this Kelvin chart. So from 1000 to 10,000 Kelvin, which is insanely hot. I find kind of around about 3,000 Kelvin or 4,000 Kelvin is a nice color to, and I'm using this purely as a baseline. This is not particularly scientific here. I'm just using it as a baseline to create my color. So I'm going to add another knot, which is going to be at the hot end, the highest density of fuel, or fuel that's burning at least. And then at this end, I'm going to actually reduce the intensity down. So you can see there's an intensity slider here. I'm going to leave the color the same. I'm going to go to 10%. And you can start to see what's happening here. I could go to 50% actually. There we go. And then at this end, I'm actually going to overdrive this. And I'm sure most of you probably know this now. You can overdrive intensities in C4D or brightness values. And what we do if we do this on the gradient, we're actually going to get a hot color. We're going to burn this out to a white. So if I go to 200%, you start to see it actually gets this interesting looking hot color. And if I go to 300%, we actually burn it out all the way to white. And this is quite a natural way of creating these fire colors. And we could even drop this one's temperature down, and you start to get hotter as it gets sort of a darker red as it starts to cool down. Right down to the bottom there. And we can also tweak this knot so that it tightens in a bit. Like that, but I quite like it at the middle point there. And then obviously we've got the fuel opacity. So let's increase the res again. Tell you what I'm going to do is I'm going to make sure that no smoke is generated. Don't worry about this crazy looking panel. We'll come back to this. That certainly is slow. Let's press play with no display on. Like I said, if you leave it on the default 32 by 64 resolution on the grid slices, you're going to have a much better time of the... Whoa, there we go. So this is our fuel that's not been burning because I turned the ignition heat up so that essentially it's not reaching the value it needs to trigger to turn our fuel into carbon or smoke. I'm saying carbon, that's way too literal. But that's essentially what happens in real life. You get carbon from, which is the smoke, little carbon particles. Okay, so we've got this gradient here, this control here. Now, obviously, I'm editing it real time, so it's going to be a bit slow. But you can see here our intensity is at 40%. If I go to 100%, the opacity in the middle is very dense. Maybe we just want it at one end. And there we go, we're getting a really hot core there. We could even go to the point where we actually drop the Kelvin off to the right, and it ends up going to a bluish color, but that's a bit artificial, I would suggest. And so we're doing this with this Kelvin slider. We can absolutely do this with just the normal color picking. So if I go to the compact view here, what you need to make sure though, if you're doing hot temperature stuff where you want it to, like a laser, anything you want to burn out to white, it always has to have lower than 100% saturation. So what I mean by that is if I go to 100%, you'll see we get this, even though we're at 300% intensity, we're still getting the orange color. Let me just, let's leave that one on there. I'm going to leave it on there. But so if you watch here, as I drop down to a lower saturation point, because I'm overdriving the intensity, we're getting a yellowy color. And if I drop it down further, we end up getting the white color. So make sure on this particular color, it's around about 70%, but it starts to white out at 300%. So, and then maybe we want to tweak the hue just to kind of get a bit more natural orange. There we go. And I think that red's way too distinct. So I'd probably go back to a sort of a bit further up on the hue and then drop the saturation on that one down as well. Just going to give you a more organic color. There we go. Cool. So this is just tweaking for the viewport, of course, but this all comes into importance when you're dealing with rendering as well. So you'll need to be dealing with this kind of color stuff. Let's make the transparency a bit higher, and there you go. Cool. If I drop them back down to their respective defaults, and we can press play, and you can see this nice fire in the viewport. Pretty quick as well. You can see it's pretty fast. Like I said, always cache or render to a hardware preview if you want to see real time. Okay, so that's our first look at the Explosia domain, what it's about, just the basics, how to get things going, which is actually really simple. We've used a torus as the source, but we can use other things as the source as well. And just to show you, we'll look at this in more detail, but the basic idea here being that we can turn the channels down based on the source object or from the source object, and you can see I've turned the heat off now, so therefore we have no buoyancy. And like I said, we'll get into this in more detail. Same with the fuel. If we have no fuel, we're actually going to get just temperature being solved, and we actually see nothing in the viewport. But if I add some smoke in, maybe we'll get some smoke. Oh no, actually, because we've got the burn down at 0, we need a bit of fuel. There we go, fuel. I think it's because we're displaying just fuel, isn't it? That's why I wasn't seeing any smoke. There we go. So I'm generating smoke here without any fuel, and we can, of course, animate these parameters up. And also, something worth noting, which again, we'll look at in more detail in a bit, is if I don't have this vibrate tag, our fluid's going to look a lot less interesting. So actually having, even though it's fairly interesting in itself, if you have an extra motion being added in by an object or by the source object, it's the way that you paint your fluid. It's the way you create the source for the fire or the smoke that's going to be showing later on in the simulation. All right, so like I said, that's a good look at the display tab, definitely. Next up, we're going to take a look in the next video at the solver tab more and the simulation. See you then.